So for the first part of the video homework, let's talk about problem 1 of video 8 of homework 8. Okay, so in the problem 1 we know that xt is a wide sense stationary process. So we have some condition like expectation of xt should be a constant, and the Rx t1 and t2 should be something related to tau, and tau is t1 minus t2. Okay, so and we also have a yt. Yt is the derivative of xt. So the first question A, we need to find the expectation of yt. And this is very easy because the expectation of yt is expectation of the derivative of xt. So which is expectation, which is a derivative of expectation of xt. And since the expectation of xt right here, expectation of xt is a constant, so the expectation of yt should be 0. Okay, and the next question B, we need to find the expectation of xt times yt. Okay, right here, this is a little bit tricky because we know that if we take derivative of the xt to 2, what would we got? We should have something like this. It's 2 times xt times x, the derivative of xt plus, right? So we take the derivative of first xt and then we take the derivative of the second xt. We can get this function, this formula here. And this is easy because we can see that this is xt times yt, right? So the expectation of xt times yt should be 1 over 2 the derivative of expectation of xt to 2, right? And this is derivative of correlation r t and t. So it's wait a minute, just the correlation of t and t is r correlation of 0, right? Yeah, so, and it's obvious that the correlation of 0 is a constant. So we have expectation of xt times yt is 0. Okay, so and next question C. Okay, question C, we want to know that if xt and yt, if they are uncorrelated, so we know that expectation of yt is 0 and the expectation of xt is whatever this constant is, but it's a constant. So the expectation of xt times yt is the product of the respective expectation, right? so they are uncorrelated. And the question D is we have to prove if xt and yt if they're orthogonal. So expectation of xt and yt is 0. So this is the definition of orthogonal, right? So it's very obvious they are orthogonal. Alright, that's all about the problem 1. Thanks for listening.